Hi, my name is Andrzej Bauer. I cannot be with you today, so I prepared this screencast in which I will explain what random art is. So essentially, random art is a program which publishes images on the web. Let me show you how this works. It's at randomart.org. Visitors come and visit the page, and they go over here. They suggest a picture name, for example, I don't know, blue fish or blue octopus. And the program uses the title as a source of randomness from which it generates an image. As you can see now, it's computing the image in high resolution. It's fairly slow because this is running in the browser. There's a native version which works much faster. So here's blue octopus. This is now a standalone program which works faster. So when an image is computed, if the visitor likes it, he or she can submit it into the gallery and then it appears on the web. Now, if you change the first word here, then you get something that is similar in style to the picture we had before. So the first word determines colors and focal points. This thing still hasn't computed. It's really slow. When it is computed, we'll submit it. So maybe we try another color here, say red octopus. You should, of course, realize that the letters of the title, they get used as a source for pseudorandom number generator, which means that there is absolutely no correlation between the meaning of the word and the actual picture that comes out of it. I'm just showing you how the style changes when you change the first word. So you can see it can change a lot. So maybe with some other word, it's not going to be like that. So if we try, say, let's try a fish. So here's black fish. Ooh, it's black. Here is green fish. See, it's the same style. Yellow. Of course, I don't have to use colors here. I could use anything. I could say, well, banana fish. It's always the same style. That's because randomness gets used in two separate parts, and the first word gets used for the first part, and the second word for the second part. This is part of a general scheme of random art, which is how to control the randomness so that there is just the right amount of it. If the pictures are too random, then they just look like noise. If they're not random enough, then they're just monochrome. So this, I think, is the most interesting aspect of random art. Getting just the right amount of randomness in so that interesting things happen. So let's submit this. It'll show up in the gallery a little later. So now let me tell you how the program works and how all this randomness gets used. So let's open a new page here. And yes, so suppose you want to draw an image. So now we need a little bit of mathematical explanation, but don't worry, it's going to be very basic. So if I want to draw a picture of some kind, and I want to present that in a computer, then one way to do this is to put a coordinate system on it so that I can have for each point I have its x and y coordinates. And now suppose I have a function which, given the x and the y, gives me a color. So a color in a computer is represented by three numbers which denote the red, green, and blue components of the color. So for example, 1, 0, 0 is pure red. Or if you say 1, 1, 0, that's red and green mixed together, that's yellow. If you say half, 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 you get gray, and so on. So suppose I have a function like that, then I can draw the picture, because for each point in the plane, I just calculate what color it should be. So how are these functions constructed. Random art takes the title and then it generates the function represented as a computational circuit. So what's a computational circuit? It's a graph of a certain kind. So, and it works like this. We start with the basic things, which are, well, of course, the coordinates of our point, and then maybe maybe there are some numbers here, like that. And so then we combine these together into what's called a circuit by using basic operations on them, like addition, multiplication, trigonometry, various kinds of functions. So maybe I compute square root here. So if I have square root, I feed it y, so this would compute square root y, and then maybe I multiply these two together. So you can think of values flowing into one of these gadgets, and out comes the result. And then maybe I do another addition, like that, and I need another argument, so maybe I do that. Okay, so here I didn't use the number 10. I could, maybe if I make a bigger one, still bigger one, say I have another multiplication, then I can do things like this. So maybe here I do plus, and I can feed the same number in twice if I want to, like that. So in normal notation, what would this be? Well, this part here would be x plus y, and this would be square root, so this would be, this part here would be x plus y square root y times square root y, and then plus 5, and then all of that multiplied by 10 plus 10. Okay, so this computational circuit here is the same thing as that expression. What random art does is it generates the computational circuit, which is then a function of x and y that determines the color. But of course, the circuit must work with colors. So see, this circuit works with numbers. So we need the more complicated kind of circuits where we can operate with colors. So that's not difficult to do. So, well, we start with x and y. Just a second here. So we start with x and y. Of course, we always need x and y. And then instead of giving ourselves some numbers, maybe we give ourselves some basic colors. So this is a basic color, or well, maybe not such basic colors, just some colors like that. And then you want to do something interesting with them. Okay, so you combine them, but now for combinations we use operations that are appropriate for colors. So for example, there is something called mix in random art. Or maybe I want this to be black. There we go. So there's something called mix, and this mix takes 3 arguments. It takes 1 scalar value and 2 colors, and then it mixes these 2 colors into the proportion of y. So if y is 0, we'll get completely green because it'll take 0% of red. If y is 1, it'll take just red and no green. And if y is 1/2, then it'll take half-half and mix, and so on. And then another kind of operator, for example, is a conditional, which works like this. So it's called if positive. It takes a scalar, and again 2 things, 2 colors, so maybe this one and that one. And the way this works is it looks at the scalar value. If it's positive, then it takes the first color, otherwise the second color. So in this example, I can actually draw the picture that corresponds to this. Suppose our picture is in a coordinate system, so that here x values go from -1 to 1, and the y values go from -1 to 1. So here 0, 0. So that's our coordinate system now looks like this. Okay, so this is the y-axis, the x-axis, that's the 0. Okay, so how do we do this? So whenever x is positive, which is on the right half of the y-axis, whenever x is positive, we take the mix. And when it's negative, we take the pink. So everywhere where X is negative, it's going to be pink. So here, the image would be pink, like that. Okay? And then over here, it will be a mix. Now, if Y is -1, so now, of course, let's interpret -1 as taking just red and 1 as taking just green. So here at the bottom, the image would be completely red here. Okay, like that. And then as you go on, maybe it will get better if I do it this way. So as you go on, it becomes slightly red, less red, and then there's just a little bit of red, and down here it's completely red like that. Okay? And then similarly with the green, up here it's completely green like that, and so you get a gradation. So here it mixes. Okay? So it'd be an image like that. With larger circuits, it's very hard to predict what the image will look like. Also, there are other operators in there, not just if, positive, and mix. I think there are about 24 operators. Yeah, so how is this? How does RandomR generate these things? So it uses the first word in the title here to get these initial colors. So everything else is composed out of these initial colors. So it picks some colors. I think it's somewhere between 2 and 10 colors. Sometimes it just picks 2 colors, sometimes it picks 10 colors. But these are the basic colors, and then all the rest is made out of these. So that's the first word. And the second word determines this structure here. So this is the second word. It determines what this circuit looks like. So it uses the random number generator, it initializes it with the second word, and then it generates this circuit. And so in the end, you get a circuit which computes the image. So I hope that's clear, how that works. So you see now that if you change the first word, then these colors will change. And also, apart from the colors, there will also be some points in the plane here, chosen points in the plane. And there are operators which need chosen points in the plane and so on. So that's why things will shift around. It won't be just the colors that change. If you change the second word, then you just get some totally different circuit, which will in general be unrelated. So keeping the first word the same might give you the same colors, but there is no guarantee of that. This is, I think, almost all I wanted to say. So maybe we go and we look here at what people think about this. So first of all, our blue octopus is here. If you see an image that you like, you can click on this to say I like it here. And then there are images sorted by popularity. So in my opinion, maybe some of these images at the top really are kind of nice. Most people think of them as nice. But as soon as you go down here, you see that it doesn't really look different from the regular page. So if we go see the regular page, you know, it's the same thing more or less. So this is pretty random. Even though people are voting, they only manage to vote for the first 3 or so, and then after that it all looks random. Also, it really is a matter of taste. I find it. Some people find certain images nice, and some people find other images nice. It differs a lot. Maybe I discuss just one more thing, which is an idea which people have when they see this, and it's called genetic. It's called genetic or evolutionary art. So they want to speak about evolution. The idea here is this. If I have 2 circuits which compute 2 images, and both images are deemed to be pretty, so I have one circuit and I have another circuit, maybe these 2 circuits can have some babies where I cross the circuits, I combine them to make new circuits. And so the new circuits should maybe, you know, there will be the cross of the other 2. And so maybe they are, if I mate pretty circuits, I get more pretty circuits, and then by a process of evolution I should get very beautiful pictures. So yes, this is an idea which I could obviously implement. I have never had the time to do it. In fact, random art was implemented with this idea in mind, because a friend of mine called John Mount, already in the early 90s, when the web was hardly there, had genetic art on the web, and people voted for images, and then the images were bred and new generations came up. And this was also done by Michael. They did this together, Michael Woodbrock. They were both graduate students at CNU at the time. So when they left, their program stopped working, and so I wanted to re-implement it, and I never got to the evolution part. I just got to the random part, and I stopped there because it kind of looked pretty. So that's how random art came about. But you can look up John Mount's genetic art. It's still running on the web. There are others. There is the famous Spot's Electric Sheep. This is Hollywood famous. It's also a form of genetic art where people vote, and this one works on people's screensavers, not on the web. It's been used in Hollywood, that's why it's famous. And Spots, he's dedicated his life to this sort of art. I'm mentioning these people because I was influenced by them. They were all my schoolmates at some point. So random art is a product of, also because of their ideas, and I just imitated them. Unfortunately, I cannot answer your questions, but maybe you can play with the program or play with the website or something. Thank you for your attention.